So if we're in 3 dimensions, because that's where the real world takes place, okay? I kind of oversimplified just by using I and J here. And, you know, I could have dealt with that, but it comes out the same. So you can kind of think why it comes out the same. You all know multivariable calculus. You can ponder that if you wish. And it's not that deep. But what we can say here is, okay, that on the average, your velocity in any direction of space will then be the same. Okay? So if on the average Vx equals Vy equals Vz, so V squared equals Vx squared plus Vy squared plus Vz squared, obviously. And I'm going to put bars over these because it's average, okay? The average of the squared velocity is, by the Pythagorean theorem, the average of the squares of the x, y, and z average velocities. And this bar over here and the 2 almost looks like a -2 or an arrow, which would make these vectors, right? But this says v bar squared, vx bar squared, and so forth, okay? And I'll write it a little more clearly here. Since Vx equals Vy equals Vz on the average, that means Vx bar, Vy bar, and Vz bar are all the same. And I could write this as 3Vx bar squared. I could also write it as 3Vy bar squared, or 3Vz bar squared, or 3V in any direction of space I wish squared. Okay? But I choose x because we're talking about implicitly a wall that's perpendicular to the I direction. Okay? So we get this. Well then, average kinetic energy in the x direction is 1/3 the average kinetic energy. Now this gets into the distinction from between average velocity and RMS velocity. I'm just going to mention right now RMS velocity means root mean square, the square root of the average of the squared velocities. Okay? And that comes about just because of this, but I don't want to go into that detail right now. I'm trying to get a bigger picture. Okay? But that's something that always confused me. Okay? When you read it in your book, maybe it'll confuse you too, because you're reading the same book I was 50 years ago. Okay? I never quite understood that, and it's really a fairly simple connection. Okay? Just because I wasn't that good a reader, I think. Either that or just because I was relatively stupid. Okay? But anyhow, there it is. And this has big implications because what it really is here is the kinetic energy you get here is your average x kinetic energy, right? If you multiply your kinetic energy by the cosine squared of theta, well, okay. Actually, I don't have enough stuff up here to point to distinguish this, but Well, I'm not gonna draw a conclusion right now, we'll just stick with this, okay?